I'll start with the demonstration of what sir has taught you yesterday, Dr. Sajan sir has taught you yesterday. First of all, how the machine works. We have to switch on and off the machine, and the machine has always to be connected via power point. So this is the machine, and we have a power backup, and this is always connected to the main UPS power point. So this is a UPS power point which we have kept. So you can see there your UPS written. So this is the main UPS power point. And don't let the machine shut down like this. You have to shut down the machine by pressing this button so that it presses and it goes off. Never ever shut like this, because the machine will go off and the motherboard will shut down. So now we'll switch on the machine. So this machine is now getting on. It may take time depending upon how the motherboard works. It may take 1 minute, it may take 3 minutes, it may take 5 minutes, it may take seconds. That's how your machine works. Once the machine is on, you will see some parameters come on this side and some on this side. Now you can see there's a blue marker which is getting completed. It means the memory is getting loaded, and this mark means that this is getting charged. So if I remove the charger, so this point will go off. So keep it always on the charging mode until the memory finishes. You can't save any of the images. So once this is on, machine is on. So what next you do is you enter the patient data. So this is from where you enter the patient data. So I'm entering the patient data here. So you can see there's something coming over here. So this point, I have to add a new patient. So I press new. So once a new and the cursor comes over here, I write whatever the name of the baby is. I usually write baby off. So whatever the name is, then the first name, then the ID number, because there may be similar IDs, then the date of birth. So the format here is 2024. The month is 08 and the date is 19. So it was day before yesterday. 1 and gender male. So whatever you enter, it will be shown there. So type of examination which we are doing is the cardiac type. You can enter the blood pressure if it is an adult patient, or the newborn you want to enter heart rate, because heart rate will be used to calculate the cardiac output. So you enter the heart rate there. Fine. Then the referring doctor, institution, department name, what ID, whatever you want. Then press the button, done. So whatever is written here is shown here. You have to press here. So the different machines have a different thing. The basics will remain the same. Okay. So now you have entered Param GP 2024 August 20th. Today is this is ID, and you can see the cardiac probe used, which is P10. And this is the name of the probe, charging done, everything done. This is a mechanical index, is a thermal index, which is of no use for us currently. Now we have entered the patient data. We have entered patient data. One thing, review means, the review button means that you can review all the previous data. Once you press it, the whole previous data comes over here. Like I want to review for the baby of Javik. So I press it here, then review it. So this was a lung ultrasound done for this patient. How many lung ultrasound? 3 images have been done, and this is third out of the third. If I press 1, this comes 1. This is 2. This is third. So this has been saved. If I want to go back to the list, whatever the images were there, I go and press back to this. If I want to export this thing to my pen drive, so this is a pen drive. I can export this to my pen drive. Like for baby of Rajni, I want to export. Then export this to the pen drive. So export into which pen drive? I have 2 pen drives. I can export any one of them. So it will show that export is in progress. This is happening. Once it is complete, it will show it is complete. I can take the data out of it and I can show you in my laptop. If you are not able to store, sometimes what you do is take the pictures from the here and then you show, which is not a very good idea, but this will give you a very good. And this has already installed software in this pen drive, that is the DICOM software. Fine. So this is getting restored. There are 28 images. So there are too many images, so it will take its own time to get into that image. Fine. So I press done, go back. Then the report, you can generate a report out of it. If I press the report button, so this is how the report will be generated, and this will be, you can take a print out of it, and then you can keep it in the file. Okay, then the setup button, which is not a very important button for us. It is for the machine. The administrator is keeping it. So the administration and audio, battery. So these are the basics of this machine which have been set. So we don't need to change the this administration setups. Clear? So this is the whole basis of what we do in the patient, the review, the report, and the setup. Okay. Now after this, we go into the basics of this monitor and this, and then the transducers. Or we can go either ways. We can go to the transducers first and then go to the machine. I think that would be a better way. So Dr. Novotam will handle this. Okay. So this machine has two transducers. One is this, and other is this. So this has been shown to you by Dr. Sarjan sir in the previous lecture. So this probe is a thumbprint probe and a phase array probe. This is a linear probe. The piezoelectric crystals are linear. This has a lens over it, and then this has a lens over it, and here is the lens cover, lens layer, and then below this is the piezoelectric crystal. This is the housing body. This is a strain relief, and this is the cable. Okay. So in the end, coming over here. So again, there is a strain relief over here, and this is connected to the transducer buttons. So if I open it, नीचे जाना है. If I open, थोड़ा सा दूर. If I open it, I can open it and put it on this side. If you don't have, you want to change, so you can again do this, but it has to be done very carefully. Otherwise, what will happen is this will tore off. इसका एक बटन होता है वो टूट जाता है इसमें से. And the similar thing happens here. Clear? Okay. So, and on this or this, like it is written over here, 6 to 13 megahertz. 6 to 13 megahertz. So this 6 to 13 megahertz means it can change its frequency depending on what structure you are doing. You can press over here, and then you can press over here the exam button. So the cardiac, neonatal, or abdomen. So it will change according to the which part you are imaging. Okay. So this 6 to 30 megahertz, and this is 4 to 8 megahertz. I think clear about the transducers. We don't have a curvilinear because we don't use in our NICU. It is used in the pediatric ICU and the adult patient, because you need more depth with this, and it will have a lesser wavelength, lesser frequency, and the more wavelength. Sorry. So this 6 to 13 megahertz would be having a higher frequency. So the higher frequency probe will have a superficial penetrance only. So the wavelength will be less because the frequency is high. As told by Dr. Sarjan, the relationship is opposite. Yeah. So this is 6 to 13 megahertz will be used for superficial structures, 4 to 8 slightly deeper, and 1 to 5 megahertz for the very deep structures. Clear? I hope that makes sense. And this is the linear probe. This is thumbprint probe. The curvilinear probe is like a convex probe, which we don't have over here. There's another probe. There's another probe. There's another probe which is also known as a hockey stick probe, which is almost similar to this, which has an even higher frequency than this. That is used for the lung ultrasound as well as the vascular pulses. That makes sense. Okay. So I can change the probe whichever I want to use. Like this is, I'm using a thumbprint probe or the phase array probes. This is a linear probe. I can switch over here from. This is the extender of the transducers. So now you will see the image becomes a linear image. Sure. Let me see that. So this is the linear probe. This is coming as a linear race. If I shift on to the other transducer, it will become as a sector probe. It will show us as a sector. So you can see this is a sector. Okay. So this is all about the transducers. If you have any doubts, you can put on the chat box about the transducers. Okay. Then the next point. So we come on to this keyboard first, and then we go on to the modes of it. So the keyboards show, I have covered it basically because, I have covered it basically Why I've covered it? Because sometimes what happens is somebody is cleaning and the alcohol or the spirit, whichever they're cleaning, it goes inside it and the motherboard gets torn off. So that's why we are covered with the cling wrap. That's just a innovation, you can say. So this is just like a QWERTY keyboard, QWERTY QWERTY keyboard. So this is how you fill the names of the patient. So then you have the tab, caps lock, shift, text button, all which we have in this. So if I press the text button, something comes over here. I can write it that this is the left side, left cranium. So this is the right cranium. This is the hemisphere. This is whatever you want to write, you can give. This is the ventricle. So you can erase it from here. Okay. So that text goes off. Same, the picture is there. Then the arrow, you can mark it over here. Then delete button. This is like just a QWERTY keyboard, nothing else. Now this button. So for this button, if you want to do an ultrasound of the heart, so I press the exam button. I press the cardiac. I press the cardiac. If I want to do the cranium ultrasound, then neonatal. If I want to do the abdomen, then goes to the abdomen. So the presets are there, which I already told you. There are some presets by the administrator, which means by the machine people. So they go according to this. This is the exam button. Clear? So I want to do the cardiac. I'll go to the cardiac and select. So this is the select button. So exam, press, selected neonatal. Now press the select button. You go on to the cranial ultrasound. Neonatal is a cranial ultrasound. I hope this is clear. Exam. Then coming on to this place. So if I press the select, I already told you, this is the stick. So if I want to move something, I use the stick. So like if I've done an image of the heart, image of the heart. So you're getting this something like color like this, short axis view, which sir will teach you tomorrow. Dr. Mohifani will teach you this tomorrow. So this is like a short axis view or a pulmonary view, whatever it is. So I save it. So if I want to move it, what I have saved, then you go on to the joystick and you can move it here. So this is how you move it. And you can also move from these buttons in this machine. This button and or the joystick. Fine, the cursor part or this part. You can move it from here. This is the basics of this. So you can move the cursor here, there, and this is the main function of this. Fine. So what I was doing is when I was doing this image, what I did, I press the freeze button. So I defreeze it. Now it is gone. I do the heart again. I freeze it. Then I can rotate it. So one thing I want to show here is when we rotate it, see this number 235. 235. It will, I'm changing it 233. So this is like a frame rate. What do you call the frame rate? So if you are having this many frames, maximum frames are 239 in this. So 239, then I come to the 1. So then 2, 3, 4, and you can see how it is moving. Fine. So if frame rate is high, my image will be better. Especially the color Dopplers, pulse wave, continuous wave, whatever Dopplers is. So I'm pressing and going forward. So these are the number of images which they have. Clear? One thing I just forgot to tell you on the, sorry for that, transducer. So the transducer has this dot, which is the indicator. And this dot corresponds to this dot. The probe indicator corresponds to this indicator on the screen, which is, if I keep it on the left side, then this will be the left side of the heart. If I keep it on the right side, then this will be the right side of the heart. So dot means a dot. Clear? And I can always change this dot. Okay. So I did this echo again. So this dot is over here, and it means I'm on this in the left side. But if I keep it like this, I'm changing the probe over here to the right side. Now you can see the structure will be inverted. So now this is the right side because I've changed it from here. So this is the probe indicator on the right side. This is the probe indicator on the left side. Left side will correspond to this left side. Clear? And if it is on the right side, then this will correspond to this right side. So don't confuse these things. So this is important. The probe indicator. Sorry, I forgot to tell this on the transducer part. I hope that is clear. Okay. So now coming on to the, so I freeze button is done. The select button is done. Now there are two another buttons, which is save and the clip. So once I am doing the heart image or the whatever the image I am doing, so if I press the save button, what it will save is the just a picture of it. So I press the, you just see when I press the save, it pauses for a second and saves this into my review. So this is saved in the storage button. If I press the clip, what it will do is it will save the whole clip. So it has saved the whole clip into the of this video in my images. So that is the storage has been done in this. I hope that is clear. So this is like an arc view. This arc view, I press the clip. So this is in saving here. You can see this blue, this. So this is saving. So 70%, 72% of battery has been used already. And I'm saving the images or the clip over there. I hope that is clear. Sorry for that. Actually, the phone call was coming. Okay. So what is happening is I'm saving the clip and the images here. So the clip button and the save button has been done. So now another is the caliper and the calculations. So what happens in the caliper and the calculation is like I am doing a sum view which is known for the measurement for the ejection fraction, which is for the ejection fraction, right? So I put some calculation over here. And I press. So there are modes, some measurement has to be done. So if I press the caliper button, once, so there's a, this scale comes over here. I won't say scale, a plus sign comes over here, which is one marker. And it takes this as a point and I measure this dimensions as a second mark. Fine. So I can now select this and save this. So now 1 and 2, the measurement is 1.65 centimeters. So it is 16.5 millimeters over here. If I want to go to the calculations, now I delete this and I go to calculations. There are some preset calculations already in this. So if I want this, says that if you are measuring this image, then either you are in the LV or you are measuring LA ratio or you are in the mitral valve. So I am actually in the mitral valve. So I press the mitral valve. It asks me, you want to measure slope, I want to EPBS, whatever you want to measure. So they want to show that. If I'm in the LV, so there will be some dimensions which they say it is interventricular septum, left ventricle dimension diastole, left ventricle dimension systole. So I can measure. These are the preset calculations which we will discuss in the next few classes. So you got the function of the clip, the save, the freeze, the select, the caliper, and the calculations. Fine. We got the this patient review report and the setup. All are done, and this is a QT keyboard. Now coming on to the another important things. So we are coming on to the other important thing is what these button means and what these modes means. These modes and these buttons. Then we'll come to this gain buttons along with this. Clear? Okay. So please, if you have any questions, keep on asking in the chat box. We'll discuss at the end, and I'll show you each of them at the end. Okay. So first of all, I'll show you this modes, and then we'll keep on pressing this buttons along with this. So now this is an image. This image is known as a 2D mode. What 2D mode tells you is the structure, the anatomy, the structure or the anatomy. So like if I get this image, it is something like a 4-chamber view. 1, 2, 3, and 4. So this baby clearly has some tachycardia, and I'm seeing the 4 chambers of the heart. I have to delineate which is which chamber. Is it a right chamber or the left chamber? Which chamber it is actually. Fine. So that is what the 2D mode does. It tells you if there is some anatomical defect and the relative sizes of these chambers. So if I want to say here that this chamber is dilated, right chamber is dilated as compared to left. So I need to have a very good image before I show this, because these are two equal, these are two equal. Fine. Just because of tachycardia, this baby is getting irritated. That's why we are looking at it's looking like this. So that's a 2D image. Fine. Now coming on to the after the 2D is the Doppler image. The color Doppler and the Doppler. So if I press the Doppler button, there comes a range gate over here. I think you can see this range gate. So this is the pulse wave Doppler. You will see here it is written PW, 2 millimeter size. We don't want to discuss this. And the angle is 0. Which sir has told you yesterday, Dr. Sarjan told you yesterday, that why it is called a pulse wave Doppler. He explained you actually in mathematical terms also and physics terms also. So if I press this pulse wave Doppler again, come over here, this button or the update button over here, this or this, any of them, something will come over here, which is like this. So these are something like EA waves or some other waves are coming. So this is pulse wave Doppler at this point. I'll show you a little better image with this. So I'm going into the aortic Doppler. So what you're seeing here is the aortic flow. This is not a very good image, but I'm just trying to show you the aortic flow. So you will measure the cardiac output from the aorta. So because it is going away, my probe is over here in the subcostal view, in the 4-chamber view, apical view. So aorta is going over here. So it is showing me a negative wave. So negative wave, I'll measure the negative wave. It tells me the velocity, VTI, I calculate it and then calculate the cardiac output. I hope that makes sense. So this is for the pulse wave Doppler. But if I have something like a stenotic flow, and the flow is very high over there. I have to shift on to the pulse wave button on the continuous wave Doppler, because continuous wave Doppler will measure along the whole line. Whereas the pulse wave Doppler measure only in the gate at that point only. Continuous wave is measuring the whole line and the pulse wave is measuring only at that point. Okay. If I measure the so it is not giving a very good picture because the pulse wave is better than this one because measuring throughout the line, which is not required here. I hope you got the understood this pulse wave Doppler and the continuous wave Doppler. So I can move the line below, which sir told you there are 5 things which we can do to make this NICU sit or the aliasing effect better. Moving the line, which is not a very good, that's just the calculation. Always shift onto the continuous wave Doppler if you have a stenotic lesion and the value goes more than 2 meters per second. I hope that is okay. Okay. So you got the 2D, you got the Doppler. Doppler are 2 types, pulse wave and continuous wave. Continuous wave only to be used when it is the velocity is more than 2 meters per second. The pulse wave has to be used every time. Okay. Then coming on to the color. So color mode, which sir told you yesterday, blue away, red towards. So wherever my probe is, this vessel, which is dividing, probably a pulmonary vessel, obviously a dividing vessel is usually a pulmonary vessel. So dividing vessel is going away from my probe. This is blue. Clear? So if I keep this over here, I change the direction. Now, if I see the same vessel, it will be showing me as red. So now you can see as a red. So this is the ascending aorta, which is shown from the parasternal, high parasternal view. If I see the same thing from the low parasternal view, it will be blue. So you will see this blue pattern over there. Okay. So another thing which sir told you yesterday, Dr. Sadi sir told you yesterday, was the scale. You can see the scale. This is 78 plus, this is 78 minus, which means 78 centimeter per second and 78 minus. So what does this mean is that if the velocity, now you see, if I decrease the velocity over here, so this is high, this is scale. So if I decrease the velocity to low, medium, this is 45 minus 45. Now see this colors. Now I'll decrease this further. You will see all are jumbled up. So the velocity is high, whereas my velocity set is the color scale set is low. So everything will show me as mosaic pattern. As soon as I increase the medium to high, you will see a better color over there. But if I go very high, so there are only three which they have said. If I go very high, 93, so even you will not be able to see the velocity here, though no color here. Why this is happening is because there is some, we should know the velocities of different chambers of the heart. We should know the velocities in the cranium. We should know the velocity in the abdomen. So if I see the same thing in the brain, and I put a color image, what I'll see is nothing. If I decrease this velocity, sorry, I have to shift to the new. So now I'm getting totally different velocities. Fine. So you will get a different image over here as compared to actually what should be getting. So you should know the preset frequencies which are there actually. Clear? Okay. So this is 2D mode. So color we have learned, this is BART, mnemonic is BART, blue away, red towards, Doppler, pulse wave, and the continuous wave Dopplers. Then comes the M mode. M mode is a motion mode or the measurement mode. Usually we say the motion mode, anything is a motion and you measure the things there. So actually this is known as a so this image is like a plaques, parasternal long axis view. I want to measure the ejection fraction. So press M mode, get in aligned with the image, which is the one part, two parts. So each part is divided as according to the line. So I'm interested in this cavity. This is the right ventricular cavity. Now this is the interventricular septum, IVS, from here till here. This IVS from here till here. This one. This is the cavity of the left ventricle. From below this, this is the posterior wall. So if I press the calculations over here, so now I'm getting directly those things which I wanted to measure the ejection fraction. So I interventricular septum, left ventricular dimension, left ventricular posterior wall, then left ventricle in systole, right ventricle wall, right ventricle dimensions, interventricular septum, left ventricle dimensions, and the left ventricle posterior wall. This is how we calculate the ejection fraction. So this is the M mode. Similarly, like we will do, which Dr. Arvind Sehgal will teach you, the LA ratio in the those parameters. So what I want to measure here is the LA ratio. So I again put the M mode. I go to the aortic valve, press update button over here, and I get something like a LA ratio. So this is from this point, this arrow to this arrow is the aortic, and this is the LA. So it is not doesn't seem to be dilated. So I'm maybe any left to right shunt is not affecting my baby. So we have the 2D mode, we have the color mode, we have the Doppler pulse wave and continuous wave Dopplers. Then we have the M mode for the measurements. Measurements can be in anything. So we looked at the ejection fraction, we looked at the LA ratio. Then we can look at the this IVC, collapsibility index. So there are many things which we can do, but basically we should understand that this is the. So the M mode is directly put in the 2D mode. So when you are working in the 2D mode, you're working in the 2D mode. So this is the IVC, and you can put the. So I'm decreasing the gain. So this is the M mode in the IVC. I can put over here and I'll show you. So you can see something line coming over here. This is not a very good image, but you should understand these are the measurements to be done in the for the IVC, LA ratio, and ejection fractions. I hope I'm clear. So what I was doing in between this modes was trying to set up the gain. I was trying to gain something from them, which sir showed you yesterday was like time gain compensation. So I am interested in one part of this image, not the other parts. So in this machine, we don't have 8 buttons, but we have 3 buttons over here. So if I want to see this, and I'm not interested in the heart. So what I'll do is I'll dim this and increase the compensation over here. So this button, then I can increase this and decrease this. So I'm seeing only this part. But if I want, I said, oh no, this is not done. So I press the auto gain. It will do work for me. So in total gain is done by this. You can see I'm increasing too much, which is not helpful. And I'm making it fully black, not helpful. So what is helpful is a middle part of it. So that is auto gain or the eye scan in many of the machines. Fine. Yes, I think we are accelerator and temporal. Okay. Fine. Okay. So I'll take. We have something to do still, but I think there are some questions. No, there are no questions. Okay. So you understood this part, the machine part. We learned something on the gain, then on the depth. So what is depth? So what I'm interested in part has to be shown in the center. So I'm interested in this arc. When I put a color, I see the arc over here, ascending, and then the arc, then the descending iota. This is seen very clearly. So if I am not interested in this, I want to see that this has to be seen with more depth. I can increase the depth. Now that arc is gone. So this depth is not appropriate. Now I'm interested in a structure which has to be in the center. But if I keep it too low, then what I'm seeing is the heart is small and this whole image is seen. So I'm not interested in this part. So this has to be in the center, whatever my interest is. So the depth has to be appropriate. Not too much, not too less. Fine. And there is another button which is known as zoom button. So if I'm interested in this area only, I can press the zoom, but this will destroy my pixels, but I'm able to see that part only. So zoom is not a very great button. Depth you have to adjust. There's gain you have to adjust, and you have to get the image right in the center. Right in the center. Otherwise, what will happen is you will see the unnecessary things which you have seen. I hope everything is okay now with this. Now, the last thing is what does these buttons? So these, whatever is written over here is the lower part is getting answer. So something, if I press page 1 to 2. So this is page 1 or 2, I go to the page 2. So this is the brightness. So this is the brightness of the screen, not of the image. So which is not appropriate, I keep the screen. This up and right, this dot is up and on the right. So now this up and on the left. So now this is down and to the left. Now this is down and towards the right. So if I want to see the heart, I can see anatomically like this also. Some cardiologists usually are interested in this part. So this is the left ventricle, this is the right ventricle, this is the right atrium, and this is the left atrium, and I can see two veins coming over. They are interested in this. I can put a color over here and show you that calculate the cardiac output. Fine. Then I can see the mitral valve, EA ratio. This will be taught all to you. The tricuspid regurgitation. So this was up, down, and this. So I can again go back. So this is again I have reached the same point. So this is the guide which we don't do because this is for the biopsies. Clips I don't want. So then I'm interested in sectors, something which can decrease or increase the sectors. Fine, which is again some dual. If I want one or two images, I can get those two images. If I press the color button over here, so something gets hide, I can hide the colors. I can show the colors. High flow, low flow, medium flow. Clear? Scale PRF frequency, I can increase or decrease the PRF frequency. So this is the scale. This we don't do variable invert. Don't press this button invert because this invert your colors. So if I press this, so now the blue is up and the red is down. See this. Blue is up and the red is down. Now red is up, below down. So red is always up and blue is always below. So it should not touch this invert button, otherwise everything will go off. Clear? Now if I press the Doppler button, so this is pulse rate Doppler. This is a gate. I can increase or decrease. I can increase or decrease. Maximum 7 and minimum is 1. Angle, which sir has told you yesterday, angle of inclination. So this is the angle of inclination. You can see this is 0 angle. This is 60 degree. And this is the minus 60 degree. Angle correction should not be done. It has to be either 0 or 180. So 0 is equivalent to 180 for us because the thing going away is again a 0. So the angle should be off. So if I press this pulsar Doppler, there's a diamond over here, and there can be a straight line or there can be a circle. This means it will measure throughout the line, and it is gives you the continuous wave Doppler. Continuous Doppler to be used only and only if there is values more than 2 meters per second. Clear? So then if I press the M mode over here, again, these are general images. We don't want anything from this. Phase 2, this up, down again, clips, because it is most likely a 2D. I can decrease or increase the sectors, which doesn't make any major difference to all of us in our practical purposes. Right? Then exam already done, this already done. I think, yes. I finished with this, the imaging and the machine part. So now I think we are open to the questions. So the questions and the chat ready. So, Dr. Rajesh sir, can we take the questions?
Hi. So,
anything missed, sir? Anything missed?
No, almost everything is covered. Well in time also. Anybody has got any questions or any doubts, you can type in the chat box.
I think you were asking these questions, huh? They have already typed something, 12 hertz, higher curvature. So
Dr. Jamal is asking, can you please explain gain and depth once more? Gain and depth.
Yes, sir. So just see this practically, which sir has told you yesterday, also Dr. Sajan sir has told you yesterday. So gain means I'm gaining the sound signal from that particular point. So if I'm interested over here, like I'll just decrease it. Okay. So if I'm interested in this point, so what I'll try to gain from here, this place. So I increase so this machine divides into half, not into 8 parts, but into half. So this is getting more signals getting from here rather than from this part. So you can see this, I've increased this. So lower part is getting enhanced, and upper part, if I decrease the signal from there, they're getting black. So the signal is down at this point and higher from this point. But if I'm interested in the upper part and not the lower part, so now I'm getting no signal, less signals from here as compared to this place. Now you see, this is getting black and this is getting enhanced. So this is, you can divide this into 8 parts, you can divide it into 10 parts, you can divide it into 2 parts, whatever your machine gives you. So this is known as gain. Gaining from that point, ultrasound beams comes back from this point. So that is my area of interest. Some machine will show you focus also here. That focus also changes here. But this machine doesn't show you the focus. I go back the eye scan. So this is what I want. The eye scan or the auto gain is one which gives me the overall contrast to this. Fine. Then the depth. Depth means which depth you are interested in. Are you interested in this part or you are interested in this part? The depth. So if I'm interested in this, what I'm doing is decreasing the depth. Decreasing the depth means this is not a zoom. Depth is not zoom. So depth has decreased. I'm interested in this. But if I want to increase the depth, so I'm interested in this part also. I'm interested in this part, further part also. That is means that the depth part. Dr. Z, this is clear? Yeah, this is Zamal, sorry, Dr. Zamal. Fine. So basically the point is, for practical purposes, this has to, area of interest has to remain in the center. Black and white depends upon which you are focusing on this point. This place, focus is on this place. So if I put a color over here, so I'm interested in this point. I'm getting a very good image and this is the focus area. And this is covering half. So this is not good. So I want to increase the depth here. So I'm getting now more than almost 70 to 80% is covered, which is not also good, but I'm not getting anything between it. So that depends upon which area I'm interested in. I hope something is clear.
Yeah.
Hands-on will be better.
So the next question is, like they are asking about the focus, but in Sonosite focus button is not there. I think so.
Yeah, Sonosite focus button is not there, sir.
Yeah, in most of the other machine like GE and Philips, it is there. So that we will show you when we will come for the hands-on session. We will show you the focus button there in the machine. Focus, as it was explained yesterday by Dr. Sajan, it was basically, where the whole ultrasonic waves, they get concentrated so that you can get a better resolution and a clear picture. So that is basically the focus button. We will explain you there. And Dr. Samal is asking, like, they wanted to know, the probe orientation marker, right and left.
Yeah. So probe orientation marker for different machines is, yeah, I can show you different. So over this, you can see there's a dot over here. So this is a probe orientation marker for this. For this, it is something like a point over here. So this is a probe orientation marker over here. So this is a dot. This is a line. This can be a light, which is lit. This can be a slit also. It can be anything. But what we have to remember is that this dot corresponds to this dot. This dot corresponds to this dot. If this is on the left side, this is the left side. If this is on the right side, then in the baby, on the baby, I'll show you. So if this is on the right side, on my side, this is the right side, then this is the right side. So now just keep on focusing over here. I'll change my probe orientation marker to left side in mine. So now this is the image what you usually see. Now I can change this probe orientation marker below towards the left with my assumption also. But for all practical purposes, in the cardiac part, this is on the left side. As soon as I will click this exam and go to the neonatal, you see this will shift on this side. If I want, this is usually on this side, on the cranial part. This will shift on this side. Fine. So by all conventions, there are some conventions in the cardiac. This is kept on the cardiac. This is kept on this side, and then other this. If I change the probe, this will change on the other side. So this is how this orientation marker will just guide you that you're on the left side or right side. This is nothing else to do. So I change this. Now this is automatically shifted onto the right side. Clear? So this is just telling you this is the right side or the left side, which orientation your probe is. Dr. Samal, did you get that point?
Yeah, I think so. This is very much clear. Hopefully, this should be clear. Very nicely and practically explained to you.